Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first four problems of Codeforces Round 863, which was rated for Division 3. So I was able to solve the first four during the contest and I was close to solving the fifth question, but I have not solved it yet. So we'll be discussing the first four problems only. So let us quickly start with the first problem, and that is insert digit. So this particular problem says that we have been given positive number of length n and one additional digit, and we have to place the digit anywhere in that positive integer n optimally such that the final number becomes as greater as possible. Right. So we have to maximize the final number, and we can place that digit anywhere. Right. So this problem is like fairly simple. By just observation, you can tell that the most optimal place for the digit is to be somewhere when the next digit is smaller than the current digit or the digit to be placed. So let me just show you some examples. For that, I'll include the sample test cases. So we are going to discuss some of the sample test cases that have been given in the problem statement. So if I talk about the first sample test case, the number is 76543 and I have to insert 4 somewhere, right? So the best place to insert this particular 4 is to insert it here, because after this the next digit is smaller. Now why does this always work? For example, if you have a digit x to place and the next digit y is greater than the current digit x, right? So for example, x is 1 and the next digit is 3, let's say, right? If you place 1 before 3, it will become a smaller number because the place value of this particular 3 gets reduced. Earlier it was like, if it was in the reverse order, it is 30, the place value of this 3 is 30, and in this case the place value of this 3 is 3 only, right? So we want to maximize the place value of the greater digits. That is why we want to place this particular digit such that the next digit is less than the current digit, right? So I will always find positions of the new digit such that the next digit is smaller than the current digit. So let us take some more example. 7058959. So if I want to insert 0, I cannot insert it here even if the next digit is equal to the current digit, just because if I insert a 0 here, these all characters will get shifted one place to the right, which is not optimal. So instead, what I'll do is I'll keep them as it is and I'll insert the 0 at the end, right? So this would be the most optimal answer, and this is also given in the sample output. So let me just show you the code for this particular problem. Now I've taken an integer n and a character c, and I take input for both of them, and then I take the string input s. Now what happens is I just traverse the string, and whenever I find that the current character is less than the input character that I have to place, I just calculate all the string up to that particular index by taking substring, and then I add the character, and then I add the remaining characters of the string. So I have taken the number in as a string input just because it is easier to manipulate it as a string, and after that I can print my answer. So I have written it like this, but you can also write it like this, right? So this is the new line. Now if I have found my answer, I can just directly return from it, and if I have not found any answer till yet, I can just append it at the end of the old number, right? And then I can just output my answer. So this would be the solution for the first problem. Now let us quickly move on to the second problem. So the second problem is conveyor belts. Now this particular problem says that we have been given an n into n grid, right? So this is the grid that we have been given. Now the special property about this grid is, if you are at this particular level, so I am saying it as levels just because it is easier to understand with this terminology. So if you are at the outermost level, you can, without spending any energy, you can just traverse the whole level, right? So this is not something that is given in the question. This is the observation that I am telling you. So the question simply says that if you are at this particular index, then you will be moving clockwise in this particular manner, right? So for this particular movement, you don't have to waste any energy. But if you want to go to any other cell apart from this particular motion, then you have to waste 1 unit of energy. We have been given an initial and final cells, and we have to tell the number of operations or the number of units of energy that we require to move from the initial to the final cell. So if I categorize all of these as levels, like each of them is a level, now you see that if I am at a particular level, I can traverse all the cells of that particular level, right? And if I'm at the second level, I can again traverse all the cells of that particular level. This is true for all the levels. So my question reduces to, what is the level of the first of the initial cell I comma j? What is the level of the second cell I comma j, right? Or the final cell I comma j? And I have to find the difference between these two levels. Like, what is the amount of energy that it is required to move between these two levels? Because once I get to that level, that particular level, that it will be very easy for me to traverse into any cell. So let me just also show it to you diagrammatically. If I have my cell something like this, so this is my grid, right? So the grids are something like this. And for example, if you are at this particular cell and you want to go to this particular cell, right? So my only motive is to reach to this particular level, because once I reach at this particular level, I will automatically traverse in this particular direction, that is clockwise direction. Yes, it is given in clockwise direction. So if I reach any cell of this particular level, I will automatically reach the final cell, right? So similarly, if I want to go to this particular cell, I can reach any of those cells of this particular level. Even if I reach this particular cell, I'll be able to traverse clockwise and automatically reach this cell, right? So I just need to find the difference between the levels. Now the problem is, how do we exactly find that to which level a particular cell belongs? So if a cell belongs, so let us consider this as level 1. So the outermost is level 1, this is level 2, this is level 3, this is level 4, right? Now interestingly enough, the question says that the value of n is always even, right? So we can divide the whole cell into two halves, right? So this is the outermost is level 1, the outermost is again level 1, then level 2, level 2, level 3, level 3. Similarly, if I do this for the columns, this will be the same: 1, 2, 3, 3, 2, 1. You would always observe that the level of any cell I comma j is always the minimum of the ith value, this particular thing which I have written, and the jth value, this particular thing which I have written. So this is not exactly the index of that particular cell, rather I have given it some values. So if I talk about this particular cell, the values will be 3 comma 2, and so this is not the address should be 4 comma 5, right? So the address should be 4 comma 5, but the values are 3 comma 2, right? So the level of this particular cell is minimum of these two values, right? That is 2. So if you observe that this is correct, and it will lie in the level 2, because this is the outermost level and this is the inner level, right? So the level of any cell is always the minimum of these two values. Now how do we derive these two values? Since the number of the value of n is even, I can write the first n by 2 values as increasing order and the next n by 2 values as decreasing order. So we don't actually have to write it on somewhere, we can just compute it mathematically, right? So this way we will be able to find the level 1 or the level of the initial cell, and the level 2 or the level of the ending cell, and we just have to print the difference between these two values, and we can print the absolute difference, right? So this would be the solution for the second problem. Now let me just show you the code. So what I have done is I have taken 4 integers n and abcd, that is, this is the coordinates of the initial cell, this is the coordinates of the final cell. So to find the level will be minimum of, so this is the level of the first initial cell according to the x value, right? This is the x value of the level. So here you see that I'm taking two values to compute the level. So this is the x value and this is the y value. To compute the x value, what I do is I take the minimum of a and n minus a plus 1. So this is just some value. So if this is 1, this should be 1, and if this is the index 1, so this particular index is actually 6. So to actually compute the value for this particular index, I need to do 6 minus 6 plus 1, that would be equal to 1. So for this particular index, the value is 1. And for this particular index, the initial index was 5. So again, 6 minus 5 plus 1, that is equal to 2. So this is how I am computing the value. The value would be minimum of I comma 6 minus I plus 1, right? Or n minus a plus 1. What do we do? Similarly, I can compute the y value in this manner, which is b comma n minus b plus 1. Now I can compute the level 1 or the level of the initial set, which is x comma minimum of x comma y. Similarly, I can compute the second level by finding the x and y values, which is c minus n minus c plus 1, and the y value, which is d comma n minus d plus 1. So this is how I compute the values, and I find the level 2, which is the minimum of these two values, and at the end I can just take the difference of it and I'll take the absolute difference. So this would be the solution for the second problem. Now let us quickly move on to the third problem. Third problem says that we have been given an array of length n minus 1 such that b of I is equal to max of a of I comma a of I plus 1. Now from this particular array B, we have to construct the original array A of length n, and each element of B is equal to max of a of I comma a of I plus 1. So let me just quickly explain you through some sample test cases. So these are the sample test cases that we'll discuss. So for example, if it is written like 3, 4, 4, 5, right? Now since the number of elements are 5, I have to take 5 spaces, right? So this would be my final answer or the initial array A. Now I observed that the maximum of first two values should be 3. So I just assign the first value as 3, right? This is good enough. Now I see that the new value is greater than the previous value, right? So there is one thing for sure, if I have assigned 3 to this particular place, I cannot assign 4 to this particular place. Otherwise the maximum of these two values would be the 4 value, right? So I have to do something different. I just assign 4 here and 0 here, right? Such that the maximum of these two values is still 3 and the maximum of these two values become 4. Now I can place this particular 4 directly here. And there is one very important thing, that if this particular number was smaller than 4 then, or like 3, then the answer would not have been possible. And we can just ignore this for now, because it says, the problem statement says that this particular array B has been formed from some array A, and we have to assume that there must exist some array A for this particular array B, right? The question doesn't mention to consider a case where the answer is not possible, so we will assume that the input is given such that the answer will always exist, right? So I can just keep this value down here, and since I'm considering the last value, I can just directly take this value, right? So the thing is, whenever we see that v of I is greater than v of I minus 1, what we can do is, we can just like keep the current space as 0 in the answer array and mark the next space as v of I, and the next space again as v of I plus 1, right? Why do we do this particular step? Such that whenever we see that the next value is even greater, we can again mark the new value here, right? So for example, let us consider some other test case like the last one here. So we are going to consider this test case. So it is 8, 1, 3, 5, 10, right? So there are 6 spaces overall. So the first space we can just insert 8, right? For the next thing, we see that the element is smaller than the previous element, so we can just directly copy this. Now you see the first two elements, the greatest element is 8, and the next two elements, the maximum element should be 1, right? So we see that the current element is greater than the previous element. If I insert 3 here, then the maximum element would become 3, which is not what I want. So I'll place 0 here and 3 here. Now since I have placed 3 here, I can just copy this particular value here. So now it will become the maximum of these two elements would be 5, which is present here, and the maximum of these two elements will be 3, which is present here, right? So I can just copy the last value again here, right? So this is how the problem is going to work, and let me just show you the code for it now. So what I've basically done is I've created a vector of size n minus 1, in which I'll take the input, and I've created a vector of size n, which is the answer vector. And I've copied the first value into the 0th index of my answer vector. So I run a for loop from position 1 to less than n minus 1, and for each index, when v of I is greater than v of I minus 1, I just set answer of I plus 1 is equals to v of I, and I just increment the value of I. Now what I do is I just set the I plus 1th index, that is the index after leaving one space, this particular index. So I was initially here, right? I just incremented my I at this particular at this particular line, right? And again I am doing answer of I plus 1, that is I am talking about this particular position, and I am setting it as v of I, right? Now if this condition is false, I just directly copy the value of v of I into answer of I, right? So this would be the solution of this particular problem. At the end I can just print my final answer. So let us quickly discuss the fourth problem. So all these problems I found, like, they were not difficult, but they were a bit tricky, and with a little bit of thinking you will be able to solve all these problems. Now let us discuss the final problem. This particular problem says that we have to consider a Fibonacci series in which the 0th element is 1 and the first element is also 1, and then the Fibonacci series continues. Now it says that we have been given a Fibonacci rectangle of order n, which means that it will have a height of f of n, that is the nth element of the Fibonacci series, and a width of f of n plus 1, which is the n plus 1th element of the Fibonacci series. Now we have been given a particular cell which has been painted, right? And we have to divide this the whole rectangle or the whole Fibonacci rectangle into n plus 1 squares in such way that each cell, that the painted cell that was initially given to us is in a square of side 1, and there is at most one pair of squares with equal sides, and the side of each square is equal to the Fibonacci number. So right, each square should have a side equal to the Fibonacci number. Now it is much better to discuss with some sample test cases. So I'll take some test cases from here. So let me just first write the series. So the first element 0th, first, second, third, fourth, fifth. So it will be 1, 1. This is 2. This is 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. Right. So let us consider this particular test case. Now what happens is I need to form a height equals to 5 like this and a width equals to 8 like this. Four, 5, 6, 7 and 8. 3, 4 and 5. So this will be something like this, right? Now what happens is we are currently at cell 4, 6. This is 1, 2, 3, 4, 5. So 4, 1, 2, 3, 4, 5. So we are at this particular cell, like this particular cell is painted, let's say. Now we have to take like the Fibonacci numbers, and the maximum that we can take, or the maximum square that we can form, is this particular value, right? So this is the maximum length or the side of the square that we can form. So you see we have to form n plus 1 squares. So these are exactly n plus 1 squares. So this is the first, second, third, fourth and fifth. So we have to form n plus 1 squares. Now the value can be 1, 2, 3 and 5, and I can repeat any one of these values at most once, right? So I can form a square of side 1, then 2, then 3 and 5, and I can take any one of these values again. So if I choose to take 1, it will be like this. If I choose to take 2, it will be like this, right? So I believe it is optimal to take the smallest value, because I don't want to like take the space of other squares, right? So if I take the smallest value, I have to form squares of these sides, right? So 1, 1, 2, 3, 5. Now one of them is already covered, right? The initial square, that has to be like this, which should cover the painted cell. Now I have to form the remaining squares of 1, 2, 3 and 5. So if I have to form the square 5, if in case you're wondering again why I've taken the number 5 only, so this is the maximum square I can form because the height is 5, right? I cannot go beyond 5 because this is the maximum value I can form. If I try to form 6, then I cannot form a square of side 6, I can only form a side of square 5. So I have to form a square of square of side 5 now. So I can take this particular square. This is 5 into 5, right? This particular area is 5 into 5. So if this is covered, then I have to now form a square of 1, 2 and 3. Now if you carefully observe this particular diagram, then you will see that this is 3 and this is 5. Now the problem has been shifted to this particular area, right? The problem is the same, it's just had been shifted one space to the left. Earlier we were at this particular position, now we are at this particular position where n is this and n plus 1 is the next value. This is n plus 1, right? So the height, you have to rotate the diagram so that this is the height and this is the width. Again, the maximum value I can take is 3 because 3 is the height. So I take this particular square, right? This is 3 into 3. Again I take this particular square. So I remove this from my remaining squares, and again it will reduce one space to the left. So now the problem is reduced to this particular space. So now this is the n and this is n plus 1, right? So the maximum square I can form is 2. So I will take this particular square and I will form this. I will form the square. Again 2 is removed and my problem is again reduced, so that this is n and this is n plus 1. Again the maximum square I can form is of side 1, so I can form this particular square and I form my last square, so it is possible in this particular case, right? So I believe that you have observed till now that this problem can be like recursively reduced to a smaller sub problem, and if we find the answer for the base case, then the answer for the whole problem exists. So we just have to transform the whole problem or divide the whole problem into smaller sub problems, as well as we also have to take care of the index of this particular painted square, because with each transformation, since we are like shifting this height and width, if you observe, then in the first case, if this was the width and this was the height, then after going to n minus 1, this particular axis becomes the height and this particular axis becomes the width. Again going to n minus 1, this particular axis again becomes the height and this particular axis becomes the width. So this keeps on going on alternating shifts, and we have to manage the index of this particular painted cell accordingly, right? So how do we exactly tell whether the answer exists for the particular iteration? So I believe again you must have observed 1, 2, 3, 4, 5, 6, 7. So these are 8 columns and 5 rows. 1, 2, 3, 4, 5, right? Since I want to form a square of side 5, right? So 1, 2, 3, 4, 5. Either it can be present in the left half or it can be present in the right half. So if it is in the left half, it will take this much space. So the painted shell should be somewhere in this particular area, right? In the remaining three columns. Otherwise, I can take it in the right half. Then 1, 2, 3, 4, 5. It will be taking this particular space, and the painted cell has to be in the first 3 columns. So if this cell is in either the first 3 columns or the last 3 columns, so what is the exactly 3? So this is the difference of the width minus height for the current iteration, right? So if the cell is in the first, this particular cells W minus H, in this case it is 3. If it is in the first 3 cells or it is in the last 3 cells, the answer can exist for the particular that particular iteration. Otherwise the answer cannot exist and we can directly return 0. So this would be the whole problem or the whole solution for the fourth problem. Now let us have a look at the code. So in this particular problem, what I have done is I have taken 3 integers n, x and y, and I have just taken them as input. So I have also pre-computed the values of the factorials up to 50. So actually it is required up to only 44 or 45. So as a safe bet, I have taken 50. Now I just call my helper function, which will recursively call for each iteration, and if it returns true, I just print yes, otherwise I print no. Now let us have a look at the helper function. So if I reach n is equals to 0, so this is my base case, I'll return 1 or 2. Now I set my height as width as height will be equal to factorial of n and width will be factorial of n plus 1. Now I just check if y is less than equals to w minus h or y is greater than h. So this is when the cell is in the first half of the columns, and this is the case when the cell is in the right half of the columns. Now I apply the transformations. So the new x and new y will be denoted as dx and dy. So the new y will be directly equals to x. I'll show you how. So now since this is the height currently and it will become width. So this is 1, 2, 3, 4, 5. So this is somewhat like 1, 2, 3, 4, 5. Let's just take it some values here. Right. So this is currently the height and this will become the width. So if I like rotate it and I observe it like this, so after rotating it, it looks something like this, and the transformation seems correct. I can take the width as this particular values. Right. This is a valid ordering of the width. Right. So I didn't change the x-axis. I just renamed dy as x. Right. Because this height is going to become width. But that is not the case with this particular y index. I have to take care of this. So if it is in the first half, like this, if it is in the first 3 columns, then we don't have to make any transformations. But if it is in the second half, right? So if the cells is in the second half, right? So the value of y will go like 1, 2 and 3. Now currently this is the height and this is the width. Let's say this was 5, this was 6, 7 and 8. So this is the width currently, which is denoted by y, and it is going to become the height, which should be denoted by dx. So I have to subtract this particular value 5 from this, so that it becomes 1, this becomes 2, this becomes 3, right? And it will denote the new value dx in the new rectangle. So I just subtract some value from y, and that value is equals to the current height, or in this case it is 5. So this becomes 1, this becomes 2, this becomes 3. So I found this particular thing just by observation. So you have to think for this, how do I transform the value such that it suits my requirements. So I just again call my helper function. I just return helper of n minus 1 dx and dy. Now if this particular condition was not true, I can just directly return 0 from there, and that would be my final answer. So these were all the solution of all the problems of Codeforces Round 863, which was rated for division 3. I hope you guys were able to understand the solutions. If you guys did, then you can show your appreciation by dropping a like on this video, and don't forget to subscribe to this channel. So till the next video drops, keep coding, stay safe, bye bye.